Morning class, again I'm teacher Rogelio and welcome to our another video lesson. Yesterday our topic is all about chords, arcs, inscribed angle, and central angle. So our topic for today is the continuation of the lesson yesterday, which is about theorems related to chords, arcs, inscribed angles, and central angles. Let's begin. For today's video lesson, here's the objectives. At the end of the lesson, the students should be able to: first, use two-column proofs in providing theorems related to chords, angles, and arcs of a circle. Second, determine the reasons to support the given statement in a two-column proof of a theorem. Maybe some of you already know what is a two-column proof, but let me tell you what is the meaning of a two-column. Two-column proof. The two-column proofs have two columns for statements and reasons. Reasons will be definitions, postulates, properties, and previously proven theorems. Let's try to prove this theorem. If two central angles of a circle or of congruent circles are congruent, then the corresponding chords are congruent. In circle O, angle XOY is congruent to angle AOB. Let's prove that chord XY is congruent to chord AB. The first statement is, in circle O, angle XOY is congruent to angle AOB, and the reason is it's given. Statement number 2, segment OX is congruent to segment OB, and segment OY is congruent to segment OA. And the reason is radii or radius of the same circles are congruent. And the third statement is triangle XOY is congruent to triangle BOA. The reason is SAS congruent postulate or side angle side congruence postulate. And the fourth statement is segment XY is congruent to segment AB, and the reason is CPCTC or congruent parts of congruent triangles are congruent. That means we're able to prove that if two central angles of a circle or congruent circles are congruent, then the corresponding chords are congruent. Let's now move on to the second theorem. If two chords of a circle or of congruent circles are congruent, then the corresponding central angles are congruent. In circle A, segment PR is congruent to segment ST. Let's prove that angle PAR is congruent to angle SAT. So the first statement is, in circle A, segment PR is congruent to segment ST. The reason is it's given. And the second statement is, segment AP is congruent to segment AS. Segment AR is congruent to segment AT. The reason is radii of the same circles are congruent. And for statement number 3, triangle PAR is congruent to triangle SAT, and the reason will be SSS congruence postulate or side congruence postulate. And the fourth statement is angle PAR is congruent to angle SAT, and the reason is CPCTC or corresponding parts of congruent triangle are congruent. We're able to prove that if two chords of a circle or of congruent circles are congruent, then the corresponding central angles are congruent. And the next theorem is, an angle inscribed in a semicircle is a right angle. Let's try to prove this one. Given in circle C, angle GML intercepts semicircle GEL. Let's try to prove that angle GML is a right angle. So the first statement is angle GML intercepts semicircle GEL, and the reason is it's given. And for statement number 2, measure semicircle GEL is equal to 180. The reason is the degree measure of a semicircle is 180 degrees. And for statement number 3, measure angle GML is equal to 1/2 measure of semicircle GEL, and the reason is the measure of an inscribed angle is 1/2 the measure of its intercepted arc. The fourth statement is measure angle GML is equal to 1/2 of 180, or the measure of angle GML is equal to 90 degrees. And the reason for that is substitution. And for the final statement, angle GML is a right angle, and the reason is definition of a right angle. So we're able to prove that an angle inscribed in a semicircle is a right angle. Thank you for your time. I hope you learn and enjoy. That's all for today.